Okay. Um, so how many elements to initialize? Now, I was able to make this function argument simply by guessing that maybe if I need to pass array to a function, maybe I just take the type of the parameter I want to pass, copy and paste here, and it seems to work. However, I'm losing the, because of this nature, of arrays being passed to other functions only by address of the first element, I do lose the number of elements. So this is pretty much artificial. I could have done this, okay? I could have done this, and it won't matter, right? So if I've just like, this was just a hint to myself, oh, this is actually an array of 5 elements, but tomorrow I might want to change this to 6 or 7 or 1700, and that is something that we completely lose. So, but first, let me just build this and make sure that it works. Missing something. Um, um, yeah, that's the whole thing. I removed an extra bracket. Thank you very much for your help. Right. So build, and then again run it. It works the same way. Now, it's interesting that we mentioned earlier that when you create the original array, in our case, it's inside the main function. If you attempted to do something like this, we know that the name of the array stores the address of the array. And it also further is demonstrated that anytime we make a function call, print or initialize, we pass just the name of the array. And that contains the address of the first element. But if we said, let's increment this address or change it somehow, it's not going to let us do that. So we say build solution again. It fails, and the error message says, it says here that plus plus needs an L value, left value. L value is something that can occur on the left-hand side of the assignments. Otherwise, has to be a variable in memory which can be assigned to, so it cannot be constant. But arrays are very primitive, and they say, no, you cannot change the location of your array, or do plus plus, minus minus, or something like this, right? You cannot, if you knew some magic address such as 1, 2, 3, 4, 5, A, B, C, D, you couldn't do that. The compiler will again say, no, cannot change array. I mean, once created, it's fixed to that specific location. So no attempts will be like that will be permitted by the compiler. However, take a look at this. It's not a problem at all, because what happens under the table is that arrays are not passed as an array, they're simply passed as a pointer. In fact, in early days of C, remember, if I wanted to have a pointer like integer pointer PTR equals null PTR, for instance, right, initialized to 0, to declare a pointer, I'm using an asterisk. An asterisk, we say, is a type modifier. What is PTR? PTR is a pointer to an integer, a special type of variable that stores addresses of integers. Okay, so I can do that. But in early days of C, the syntax was this. Okay, it was actually a set of empty square brackets to declare a pointer. And this is just a remnant of that artifact long time ago. So in other words, it wouldn't, let me just delete this because this was only for the demonstration. Let me assure you that ARR is simply just a pointer, okay? The arrays are passed by address of the first element. Guess what stores elements such as integers in computer memory? It's simply a pointer, right? So when you pass it like this, ARR, whichever way we use, like let me just get back this the way it was originally, even 5 back. Either way, ARR from the compiler standpoint, either way, this way or this way, right? This or this. ARR is actually the type of this object, ARR, inside our functions is a pointer. In fact, what's even more confusing is that if I do switch to a pointer notation like this entirely, okay, and if I say build, in fact, let me clean first, so remove any previous build files to make sure nothing is reused, and then say build, just build again. You see how I never updated my prototypes? And even then compiler said, it's just a pointer, so both are pretty much the same. So I'm just trying to stress to you that all we do in this situation is that when we want to pass arrays to other functions, we pass them by a pointer, right? So that would be the proper, perhaps, less deceiving or more straightforward version of our functions. Just to say, hey, arrays are passed to functions by pointers, right? So ARR here and here are pointers. And the pointer type is normally declared as name of the variable, asterisk, and then an integer, right? But with this change in mind, again, here I already made my change. Okay, I already made my change here, but you don't have to change anything with square brackets over here because pointers can be dereferenced just like an array simply using the square bracket notation for the individual elements, right? Because when you have a pointer like we do, right? So let's just clean this up just one more time. Right? So we have a stack frame that belongs to main, right? So this is not an executable code. This is just a data that main has access to, right? And it has an array of 5 elements that we create like this, number 1. And number 2, we call a function named, I don't know, init or print, right? It gets its own variable, and that is a pointer to the first element of the array. And basically, when we use this, we call it ARR, okay? And so when we say ARR, square bracket index, right? And that index ranges from 0 to 1 to 2, 3, 4, right? We have this range of indices that we use. Every time this expression simply is a point, is basically an access to the value of each specific element, the access to the specific element. So ARR 0 is absolutely undistinguishable and is precisely the same as asterisk in front of ARR. If you say both equals, I don't know, 100, these are, from the compiler standpoint, the two statements are exactly the same, right? So basically, the square bracket notation is mostly used with blocks of memory, such as an array of integers or characters or doubles or some other type of objects. And the dereference operator, like this, the dereference of the pointer, is used mostly with single type of elements. Like when I have a single integer and I pass its address to some other function, and then I want to access the element that the pointer is pointing to, I would use an asterisk in front of it because it's more natural to simply dereference the pointer and say just go to the location where you're pointing to and use that value. And I can either update it or read its value.